Astronomers have discovered a nearby star which is almost a perfect match for our Sun, suggesting the two could be stellar siblings. Details of the star, named HD 186302, are reported in the journal Astronomy and Astrophysics. The study's lead author, Vedan Adebakian, from the Portuguese Institute of Astrophysics and Space Sciences, says since there isn't much information about the Sun's past, studying stars similar to the Sun will help astronomers better understand where in the galaxy and under what conditions our Sun was formed. The Sun wasn't born in isolation. 4.6 billion years ago, together with hundreds, maybe even thousands of stellar siblings, the Sun was formed during the collapse of molecular gas and dust cloud. There's good evidence to suggest that this molecular cloud collapsed under its own gravitational force after being hit by shock waves from a nearby supernova event. A classic case of life from death. As time went by, the stars in the solar cluster disbanded and scattered throughout the galaxy, making it very difficult to find them. To try and track down some of the Sun's siblings, the authors used data from the Côte d'Azur Observatory's Ombre Galactic Archaeology project, together with data from the European Space Agency's Gaia mission and observations from the European Southern Observatory, giving them a sample of spectra from some 230,000 Sun-like stars. Their aim was to go through this data, looking for stars with the same chemical composition as the Sun. That same chemical composition would mean the star may have been formed in the same molecular gas and dust cloud as the Sun. Eventually, a single solar sibling was found, HD 186302, a star in the southern constellation of Pavo, only 184 light-years away. As well as being the same age and composition as the Sun, HD 186302 is also a spectral type G3 yellow dwarf star, very similar to the Sun. If it really is one of the Sun's siblings, any planetary system around HD 186302 would also be a good place to search for life, as life originating on one planet orbiting a star in the Sun's stellar nursery could easily have been transferred to another planet through asteroid impact, the impact ejector being thrown into space and any life transferred via panspermia. Adebakian is cautiously excited about this possibility, saying there are some theoretical calculations showing that there's a non-negligible possibility that life spread from Earth to other planets or exoplanetary systems during a period known as the Late Heavy Bombardment, some 3.9 billion years ago. He says if HD 186302 has a terrestrial planet in its habitable zone, it could well have been contaminated by seeds of life spread from Earth. That would mean an Earth 2.0 orbiting a Sun 2.0. And as you'd expect, the authors are now planning a search for exoplanetary candidates orbiting around HD 186302. This new solar sibling discovery is a far better match for the Sun than the previous nearest match, HD 162826. That was discovered back in 2014 and covered on SpaceTime's predecessor program, Star Stuff. HD 162826 is a spectral type F yellow dwarf star, about 15% more massive, 500 Kelvin hotter, and about 100 million years younger than the Sun, with a 3% higher metallicity. The star is located in the constellation Hercules, about 110 light-years away, and can be seen with a small backyard telescope near the star Vega. I'm Stuart Gary. You're listening to SpaceTime. A new study shows that one of our nearest neighbouring galaxies, the Small Magellanic Cloud, is slowly dying. The findings, reported in the journal Nature Astronomy, show powerful outflows of hydrogen gas streaming from the satellite dwarf galaxy. These molecular gas and dust clouds are needed to maintain star formation. And without this supply, the galaxy is gradually losing its ability to form new stars. Astronomers made the discovery while examining the galaxy in the finest detail ever, using the CSIRO Square Kilometre Array Pathfinder Telescope ASCAP in outback Western Australia. The study's lead author, Professor Naomi McClure-Griffiths from the Australian National University, says the features of the radio images were more than 3 times finer than previous Small Magellanic Cloud images, allowing the team to probe the interactions between the small galaxy and its environment with far greater accuracy. She says this constant outflow of hydrogen gas means the Small Magellanic Cloud will eventually stop being able to form new stars, and is doomed to gradually fade away into oblivion through a slow death. The discovery, which is part of a project that investigates the evolution of galaxies, has provided the first clear observational measurement of the amount of mass lost from a dwarf galaxy. The findings are also important because they provide a possible source of gas for the enormous Magellanic Stream which encircles the Milky Way galaxy. McClure-Griffith says ultimately the small Magellanic Cloud is likely to eventually be gobbled up by our galaxy. CSIRO co-researcher Dr. David McConnell says ASCAP is unrivaled in the world for this kind of research due to its unique radio receivers which give it a panoramic view of the sky. The telescope's capable of covering the entire small Magellanic Cloud in a single shot, imaging its hydrogen gas with unprecedented detail. And that's important because hydrogen is, after all, the most abundant element in the universe and the main ingredient of stars.